Welcome to another A-level chemistry, topic by topic. We're going to have a look at some organic synthesis today. We're going to have a look at starting with any particular chemical, seeing what we can make. And when I've gone to my A-level chemistry lessons, sometimes I've left one of these things on the board and I've had other staff say, "Oh, I don't really want to rub this out. It's really useful." And many students have said this has been useful in the past, so let's have a go and see if we can create one of these things to work out how we can turn one chemical into another. And this is thanks probably to my chemistry teacher, who I had many years ago, who developed this, and I thought it was a good idea. So I'm going to pass it on to you. Let's have a look at what we can do. Right, we've got to choose something to start with one of these chemistry sort of syntheses. And probably one of the best places to start would be an alcohol. So let's see if we can draw in an alcohol. And what I'm going to do is I'm going to just try and draw in a few little boxes. And I'm just going to use a template here to sort of a little stencil just to try and make life a bit easier. So we're going to start off with here an alcohol. And going along with this alcohol probably means that we've got to have some idea of what it is. So this is going to be R. And I'm going to leave it as CH2, CH2, OH. Now, in fact, this doesn't have to be that long, but we're going to leave it like this because we're going to see what we can basically do with it. Okay, so that's where we're starting from, and let's see what we can actually do with this alcohol. And one of the things we can do with an alcohol is we can turn it into something like an alkene. Sorry, an aldehyde. Let's go aldehyde first. So this we can go to an aldehyde, which is going to be R CH2 C HO. So we've got an aldehyde. Now, how would you make an alcohol into an aldehyde? And that's where we're going to start here, trying to think about how we're going to go in basically both directions. What we're going to need to go one way and what we're going to need to go the other. And to do this is quite a simple sort of process, and what we're going to need to turn our alcohol into our aldehyde would be, I'd use potassium dichromate, and we're going to zoom in here so you can see what we're doing. And if I'm going to do that, I'd also need some H2SO4 as a catalyst. To go the other way, then what I would normally use is, for this, sodium borohydride, NaBH4, and when I do this, we normally need, as well as this, water, and we can turn from an aldehyde to an alcohol. Good start, I suppose, but what we want to do now is we want to turn our aldehyde into something else. And what we could do with our aldehyde is I can turn that into a carboxylic acid. nearly enough room to put that in. And here I've got our CH2 COOH. To achieve this, then all I need to do is to simply reflux it. So let's try to be consistent with the colors, and I will reflux with K2CR207 plus, of course, it's going to want this acid. If I want to try and reduce my carboxylic acid to something else, then basically I'm going to use sodium borohydride again. This is actually going to go all the way. So in this case, we're going to have a little problem that if we want to add that route's not basically going to work because it's going to go far further than that. So what we'll do is I think we'll just take this one out, and I will put that one in as a longer route, which is going to make its way all the way to an alcohol. Okay, now a carboxylic acid. Let's see if we can do something with our carboxylic acid. And what I'm going to do now is discover that that's not going to fit. That's better. And our carboxylic acid we can turn into something like an acyl chloride. So to make our acyl chloride, then what I would do with this one, let's just write down what acyl chloride is going to be. To make that, then what I would need simply is SOCl2. I should have done that in purple. See, I've forgotten already. And if I want to go back, then simply water is normally enough that we need to make this one go back. Right, so we've got a structure here. Let's now see what else we can do with this. So let's go back to our alcohol and decide what we can do with our alcohol. And one of the things that we can do with our alcohol is I could perhaps turn it into a haloalkane. So let's try and put in our haloalkane. To convert into a haloalkane, and back again. So how do we make this into a haloalkane? Then I would normally have something like sodium halide, something like NaBr, and I'd use H2SO4. To make it go the other way, then I will just use some sodium hydroxide. I'm not writing the full synthesis down here. I'm just writing down enough so that I can remember what I'm doing. From here, this haloalkane, I can make something like an alkene. So let's draw in an alkene. And this is going to give me our whereas our haloalkane would have been something like that. It's just an example. To turn a haloalkane into an alkene, well, that's more problematical. I could do that from an alcohol though. So an alcohol, we can do this with H2SO4, and I've made there an alkene. And if I want to make my alkene into a primary alcohol, then I would do something like adding phosphoric acid and water. So let's help this one back up. So that's given us a little bit of a chart so far to try and work out some things. Right, now let's try a couple of other things. I'm going to shove in here an ester. So with an ester, we're going to make that from an alcohol and simply a carboxylic acid. So let's have a look at this process. My alcohol then to make an ester is simply going to be a carboxylic acid plus H2SO4. And on the other side, I can make this from a carboxylic acid simply by adding an alcohol plus sulfuric acid. So the process is starting to build up here. We can see what we can do. Now, from my haloalkane, let's see if we can make something from my haloalkane. And we should be able to make several things from my haloalkane. I would think from my haloalkane, one of the things I can make is an amine. So let's see if I can make an amine from this. So this is going to be RCH2, and then it's going to be CH2NH2. How would I make an amine from this? Well, not going to be that difficult really. To make an amine, I would use ammonia and basically ethanol. So we can convert to an amine. If I hadn't wanted to go to an amine, I could use my halogenoalkane to make a nitrile. And my nitrile group going to have my CN on the end, and to make my nitrile group I would use something like sodium cyanide. I can convert my nitrile to an amine if I want to, and that one is going to be using hydrogen and a nickel catalyst. What can I do with my nitrile? Well, my nitrile, I can get clever, and with my nitrile, we can go all the way up to a carboxylic acid. And to do this, I would just use water and HCl and do a hydrolysis. And in this way, I can start with an alcohol. I can go to a haloalkane, to a nitrile, to a carboxylic acid, and then using sodium borohydride, go back to an alcohol, and I have added a carbon to a chain. And this is really quite useful. We've got my acyl chloride. This can also go to an ester. And there we are. You should have used a nice black line there. I forgot. Whatever pen I had in my hand at the time. And this is simply going to be by adding an alcohol. I didn't draw in the thing for an ester, did I? Yeah, this is going to be more fun. There. Not quite enough room to get the bin in with the box. Okay. Now, with the acyl chloride, I've got two options what I can do here to make an amide. So let's see if I can do this one. So how would I turn an acyl chloride into a primary amine? Then that is certainly just going to be using ammonia. If I wanted to make it into a secondary amide, then I'd had to do a little bit of playing around. And for that, we would have needed to use basically a primary amine. Right color, Philip. Not necessarily going to have enough room here to do this. But we've managed it. Okay, so I've done acyl chlorides, carboxylic acids. I suppose an aldehyde is the next one I need to try and work out what I can actually do with an aldehyde. An aldehyde, I know I can make an hydroxynitrile. And I'm running out of room. So let's start getting a bit more creative. So we're going to make something here, hydroxynitrile. And if I'm going to make a hydroxynitrile, then I'm going to need basically something like sodium cyanide. And I would suppose acid as well. Right, I'm getting the feeling that I've done probably enough on some of those. Let's see what else I can try and do. My alkene. Let's see if we can take my alkene down here And I'm going to turn my alkene into an alkane. Normally when I do this, I have this a bit more sideways, which I'm left with doing this one vertically, which is not as easy. Okay, so we can make this into an alkane. Alkanes really fairly useless sort of chemicals. We can't really do an awful lot with alkanes apart from basically burning them. And to try and make this into an alkane, then I would normally just use something like hydrogen and a nickel catalyst. So we've got that one done. My alkane, I can change into a halo alkane. And by turning this into a halo alkane, then I would simply do this by using a halogen plus I would use something like UV light. So we're building up a synthetic pathway that we can use to go around and try and work out all types of things. We've got one difference here, that if I've got a secondary alcohol, then this wouldn't make an aldehyde but would make a ketone instead. And if we take an alkene and we play around with this time a halo alkane, just something like HBr. Let's see what we can do here. So let's so with this one, and I can take my alkene and basically if I just add two here, I suppose really we want to go this way, and this is if I simply add something like HBr, and that would probably do that one, wouldn't it? So I'm saying an alkene, HBr, yeah, that will do, that will make it. Whereas if I do it the other way, we might get here our secondary alcohol. Didn't do that right, did I? We might as well rub it all out if we're going to do it properly. Let's zoom in for you. Right, okay, so this was our secondary alcohol, and this is going to be my RCHOH CH3, and if I can then use that one, I can make simply up here a ketone. And that one's going to be R C double bond O CH3, and to turn a secondary alcohol into an aldehyde, over here we use dichromate, and we're going to use exactly the same thing to make the ketone. And I would use, for that one, H2SO4. Ketones don't do much once you actually manage to make them. And so we've got here some sort of synthesis chart which is reasonably good for most of the sort of chemicals that we're actually going to play around with in chemistry. And what happens here is that someone will usually say to you, I've got one of these things, I want to make something else. And what they will usually do is they'll give you one of these things, but they'll miss something out. And this makes life sort of reasonably difficult, I suppose, because you have to sort of jump from here to there or whatever. I might be given an acyl chloride and I need to make an alcohol. And you have to realize you might need to make a carboxylic acid before you can make the alcohol. We might want to try and make a nitrile given an alcohol, and you've got to work out you're going to make a haloalkane first before you can make the nitrile. So we've got lots of these different pathways that we can use to try and create all types of things. And we can, in fact, find that there are a few more reactions than we've actually got here to turn a few bits and pieces into other things. But generally, what we've got here is more or less it for what we want to do. So what have I forgotten? Yeah, I can also turn my ester into something else. I've got my ester. I'm looking at that one and deciding I can turn an ester into a carboxylic acid. That would just be dilute acid hydrolysis. So, acid hydrolysis. You're seeing this quite big, but my pen's really quite small in comparison here. Right, okay. So I think that is probably it for this chart. I'm trying to think of anything else that I may have missed out. And I think that's everything. So let's do the same thing, but this time I'm going to do another chart, but this time I'm going to do it for benzene. Now this is where this usually goes horribly wrong, because I'm trying to draw benzene and I'm incredibly bad at drawing benzene. And I did have a look for a nice little template to draw this from, but I seem to have lost it. Right, okay, so let's start with my benzene and think about what we can do with the benzene. So the first thing I can think of doing with my benzene is making one of my favorite chemical compounds, which is going to be nitrobenzene. benzene. My son's given me a template. I have a feeling it's got a problem with this template. Yep, there's the problem with the template. I need a pencil. Let's just see if I can draw them quicker with a template than otherwise. Or I'm going to give in. Oh, this is going to be way too slow. We'll cheat. We'll just get you to live with me making grotty pictures. Let's zoom in so you can see what I'm doing. And this, we're going to make an NO2. And to make our NO2, then I would start with one of my favorite mixtures of having HNO3 and H2SO4 to try and make this stuff and to try and do a nitration. Once I've got that, then there's nothing to stop me taking this one and drawing in this the right color. And let's turn that. They're not that bad, these. Into an amine. To do that, I would need to use tin and HCl, and that's going to make that. If you wanted to get clever, I suppose, there's nothing to stop you then taking that and going mad. By brominating this, if we just shove some bromine in here, then it's going to stick at the 2, 4, 6 positions. There. Whereas had I just taken the bromine onto my benzene, then this would only have positioned it in one place. And that is going to be a little bit harder work, because for this one, we'd need to use Br2 and something like Fe Br3 to try and get that to work. Similar way, I suppose, I could take chlorine and shove that on here using something like chlorine plus, and this time I'd probably use aluminium chloride, sort of, to do that one. Did it the wrong color again, don't worry. Let's see, let's make toluene. And to make toluene, then we're just going to start off with my benzene, and I would use something like CH3Cl and aluminium chloride. That would do that. Do an alkylation. Similar way, I suppose we can do an acetylation. So let's take our bromine and let's make here something fairly easy. Let's just put an acetyl group on here. And to do that, I would start with something like CH3, COCl, and I'd use with that my aluminium chloride. If I took that, I suppose I could add to this something like sodium borohydride, and I could reduce that and that's given me a few of these reactions of benzene and perhaps some of its derivatives that we could have made here. I suppose one of the things we want to do is perhaps do some other reactions of benzene. Let's see if we could turn benzene into something else. And one of the things that would be quite nice to turn it into would be something like phenol. Now, trying to turn benzene into phenol is sort of a little bit more interesting. It's not one that's covered in the syllabus here. But start off with phenol, and we can then try to start with phenol and start turning phenol into various other things. I could take my phenol and I could nitrate it. This is much more fun trying to play around with. And this is going to put it at 2 positions. I'm either going to put it here or I'm going to put it down there. And if I wanted to do that, then simply all I'm going to do is add my HNO3 to try and make that. Right. What else could I do with this? Well, I could brominate it, I suppose. And if I want to brominate this, then it's going to be much more fun. So we've got OH, and if I'm brominating it, then basically I'm going to get in at these 3 positions. I could also perform a neutralization while I'm thinking about it. So bromination yeah, all I'm going to do is add bromine there. If I'm going to do a neutralization, I would add sodium hydroxide, and this is going to get me something which is pretty then horrible, which is this ONA. Now, if I want to try and make my phenol, this is a little bit more fun. And let's jump back up here. And I've previously made my amine. And if I then take my amine, what I could do with my amine is I could make my N2 plus Cl minus, and I would do that by adding sodium nitrite and something like, I don't know, concave Cl. And I'd have to keep it cold if I wanted to try and do that. And then if we add water to this, there I've made my phenol. And again, that would have to be kept cold to do that. So it's a long way round trying to make my phenol. Trying to get the phenol from benzene is a much longer route. Going first of all through the nitrate to the amide, and then much more complicated on trying to pull it through this thing to my phenol. So quite a long route. And that one I'm just going to label as being complex. It's the complex that's done up the top to try and make things. So we've got then quite a route for playing with, there we are, just about to see it all of these derivatives of benzene. So quite a lot there with benzene. So makes quite a difficult sort of thing to try and play with. So what with one sheet and another, you've got a fair number of things to go and do. Let's go and have a quick little play and see if we could make something like a primary amide from an alcohol. Let's have a look at this. So I want to make a primary amide from an alcohol. So let's start off with my alcohol. And what I'm going to do here is I'm going to just make some of these up with snatoms quite quickly. And I think what we'll start with is, yeah, we won't go too complicated here. I think I'll try and keep it relatively simple. So here's my alcohol, and I've chosen here propan 1-ol. Right, our first job will be to take this, and if I want to get to an amide, so my route is from an alcohol to a carboxylic acid. I'm going to do this in one step by refluxing it, and to do that, then I'm basically going to add on an oxygen group, and this is going to make my carboxylic acid. So propionic acid. Right, now if I react this with SOCl2, then I can turn this into an acyl chloride. And that is going to lose that group there. Now we've got my acyl chloride, then we can make a primary amide by simply taking something like ammonia and if I can react my ammonia with this, then we're going to achieve an amide. So that's one particular route for making one chemical from another, which gives you some idea about how we could play around with these things. Let's see if I could perhaps make a ketone from an alcohol. So let's start again with an alcohol. And for argument's sake, I'm going to start with the same thing. Right, now I want to turn this into a ketone. How am I going to do this? Well, my first job is we're going to have to turn this into an alkene. So to do that, we're going to use H2SO4. And what that's going to do is it's going to make me into an alkene. Right, I've got my alkene. Now what we need to do is turn this alkene into an alcohol. Now, to do this, I'm going to add phosphoric acid and water, and what we're going to get is a rearrangement of what we had before, but this time we've got a secondary alcohol formed. So we've gone from a primary alcohol to a secondary alcohol by going to an alkene. Now, you don't all make that, of course. We have to purify some of this. And then if I add some potassium dichromate and acid, then this should, with a bit of luck, form my ketone. And I've made here acetone, or propanone if you prefer. One last one I want to do is I want to try and add a carbon. This is quite a popular type of thing to do, and when I started off, this was probably one of my favorite sort of reactions that I had to try and achieve, and how I could start off with a large amount of this, and by the time I'd actually synthesized a carbon with that much more on, what I was quite surprised was if I started off with about 1 litre of this stuff, then I could probably guarantee to have something about 5 mils of my new product, because each time you go through the synthesis, different things happen and different things go wrong. So let's turn this into this chemical, but I want to add 1 carbon. So we've got our alcohol. Well, I want to turn this into basically a nitrile. I've got to try and add something like my CN on there, and I better make up my CN because I'm going to want it in a minute. There we are. And I would probably have something a little less dangerous than HCN. So this is sodium cyanide. Right, let's start then. I've got my alcohol. First thing we're going to have to do is turn this into a halo alkane. So I'm going to take my something like sodium bromide with acid here, and this is going to put on that group for me. So I've made my halo alkane. Let's react it with the cyanide, and this is going to put the extra carbon onto what we've got. Now we take water and HCl, do an acid hydrolysis, and what that's going to do, it's going to knock everything over, and these are around the wrong way. I'm going to make my carboxylic acid. Now this is butanoic acid. Take sodium borohydride, and that's going to add my hydrogens, and we're back where we started, except now I've managed to add a carbon onto the chain. That because it's going to take a while before the live presentation finishes, but I will put them up for you so you can grab hold of them, which saves you trying to create them. And what we'll do is I'll see you next time. Now we've more or less done most of this, and we're going to try and look at next time doing a bit of analysis, and for that I'm going to need some help. And so I'll bring in my resident expert on doing all this, because I'm an old chemist. And when I was at university, there was NMR, but we weren't allowed to look at it because it was brand new. And all I've done is infrared and ultraviolet spectroscopy. And I'm good at doing those. And I've learned how to do NMR, but I'm nothing as good as my expert. So next time we'll bring him in and we'll have a look at taking an unknown substance and trying to identify it. So if you found this useful, then please subscribe, and I will see you next week. Take care. Thanks for watching. Bye-bye.